we're going to be doing a complicated example now in chapter 10, more in the analytics field, even though it overlaps a lot with statistics. Let's pick the problem, and we're going to solve it. Chapter 10, number 4, data mining problem. We're going to solve it by using the book's help step by step, and we'll play along with the Excel file. So we have a bunch of data. I forget how many. And we have cars with slower engine, faster engine, fastest engine, and let's just see the data. And some of them have warranty, some of them have different type of wheels, sound systems, other options. We want to know how these guys are related. It's over, so we can see that icon to copy it into Excel. Then we get rid of this. We open it in Excel. I was that already. Downloads. This is data. Oh, this is what we're going to be using. Now we have an Excel file. So let's implement rule 1. So we're going to be doing this twice. That we're going to be testing. If then, that's the key logic here. If fastest engine, then traction control. Are these really related? If fastest engine, do we find traction control? So we're doing what's called an association analysis. If part, consequent is the then part, and we have item sets that do not have any items in common. Let's see, solution procedure, we use Microsoft Excel. Copy the data. We copy the data. So far, so good. Now, identify the antecedent and consequent to rule 1. Well, obviously, it's fastest engine is the antecedent, and the consequent, if then, traction control. Fastest engine, traction control. Continue. The data for the fastest engine is column C. Call it C:C, without specifying the numbers. And the traction control is found in column N. Let's just verify that with, there is my Excel. Column N is the Nancy, is traction control. So we have to do the following relationship between them. Column C and column N. Continue. Measure the strength of dissociation. We like to know how many people are in both categories, antecedent and consequent. That's called the support. So how many people are found in it? All right, so we could do that. Let's see that. Back again to the Excel. We could do it by hand. Let's get rid of A and B. We just see column. I'm going to hide it. D, E, F, G, H, I, K, L, M, hidden. Fine. So how many are both in both? 1, 1. Here's a 1, 1. And here's, well, we can do it by hand, or if you use what's called, if you multiply this times this, the only one that will have a 1 will be if they're both 1s, because 0 times anything will be 0. And we could do that. Well, it's rule 1, because again, and we want the support. Support is how many people are found in both categories, and how many rows do we have? We have 50 rows from 2 to 51. So it will be whatever that number is, how many ones in both categories divided by 50. So some product is a nice way of doing all those found in column C times column N. So we're going to do C true through C51, comma, N2 through N51, close parenthesis, divided by 50. Whoops. Okay, and the answer is 0.6. I'm not sure what we did wrong there, but divided by 50. Okay, the answer is 16% or 6.16. Let's check it out with the continue. Looking for ones in both columns divided by the number of rows. They use the sum product, like I just did, divided by the count. I guess we could, instead of saying 50, I could have said count, found in any and the number of rows. The answer is 0.16. Oh, we're good. Okay, now we want the confidence. The confidence is the probability, is a conditional probability. What's the probability of a consequent given the antecedent? So in our case, and if you recall from the earlier chapters, that probability is found in two steps. First, you find the probability of both those things happening, antecedent and consequent, which we know is 0.16. We just did that, antecedent and consequence, divided by the probability of the antecedent, which is the column C. So it's 0.16 divided by how many ones there are in column C. Let's do that. We can take we can add up all the ones and divide it by 50 will be the same as calculating the average, which is correct. So we can get this probability of support. This is called the confidence. And it's equal to the average, parenthesis, found in the antecedent, which is column C2 through C51, 50. That's going to be divided by, no, divided by 0.16. Remember, we have to take the 0.6, no, sorry, it's the 0.16 goes on top. Let's just do it in two stages. 0.44, so it's point equals 0.16 divided by 0.44. That comes out to 0.363. So the confidence is 0.363. Let's see how we're doing. So it's 0.6, it's 16 on top and the number on the bottom, continue. 44, 0.364, we got it right. Look at that. Oh, I'll show you that. 0.364 when you round it to three places. Okay, we're in a roll. Okay, now the third possibility is the lift. Lift is defined as the ratio of the confidence to expected confidence. Now we know the confidence is 0.364. What's the expected confidence? The number of transactions that include the consequent divided by the total number of transactions. Like reversing the other thing. Okay, so we know the expected confidence is 0.364. I'm sorry. So how many ones are there in column N, the consequent column? So we have the same thing we saw before. So lift is going to be equal average N2, which is a consequent, through N51, 0.36 as we just saw, and it's going to be 0.363. The final answer is going to be point equals 0.363 divided by 0.36. And that comes out to 1.01, which is bigger than 1, which means it's good. And let's check it out. Continue, 36. And 36 over 1.01. We got it right. Continue. And now they tell you to go through the same thing for rule 2, which I'm going to let you do on your own. Save time. If there's any question, of course, you can email me and I'll explain further, but I think it's exactly the same. Just using different columns. We can run through it if you like. I'll have it on the video. You can stop it step by step. Now we have a lift of 1.93, which is really good. And yep, so completed. And done.